Alright, so we have this box. It's being pushed on by a force MP, and there's a resistance against it, which is MKV. So you can tell that force, which is mass times acceleration, is made up of this MP. I'm assuming here it's going to the right, and it's winning against this friction. So we can see acceleration will be P minus KV. If I make acceleration equals 0 to find the initial, so initially write down the force balance equation and hence show the speed which results in this force V0. Alright, so when A equals 0, so let's put a 0 there, we get P minus K sum V0, and if we make K V0 the constant, the subject, and then V0 there, we get P on K. Alright, so that gives us a 0 net force, so the acceleration would be 0. So 0 net force, acceleration is 0. So that's when acceleration is 0. So now it says integrate. Alright, so we know then that dv dt is equal to our P minus KV. If I tip that upside down, I've got 1 on P minus KV. So let's integrate 1 on P minus KV with respect to V. So I need a minus K, so I might need a minus 1 on K, and then it's a nice log. The derivative of the bottom is at the top. And I'm assuming it's going to the right here, so this is going to be positive. Alright, so we also need a plus C. Now, if I want to get, I can see the equation I'm looking for certainly does not have a P in it. So I might change that P now using this equation. So P is KV0. So let's put a KV0. And I'll factorize by that K at the same time. Alright, so how to find the C? So we know the initial velocity. So t equals 0, the initial velocity is vi, v equals vi. Alright, so let's do that. So you can see here that c is going to be equal to 1 on k log k v0 minus vi. Alright, that's our c. So if I put it back in, I'll just move down. Back in the equation, so we've got t equals minus 1 on k log k v0 minus v plus 1 on k log k v0 minus vi. Alright, let's times both sides by negative k, so this will just be a log k v0 minus v, and it's a log is going to be a minus log, so I'm going to put this under here. That'll be a vi. You can see the k's will cancel there, so actually I can say e to the minus kt is going to be v0 minus v on v0 minus vi. Alright, we're getting closer. Remember, we want v as our subject, not t, so that's why we're going step by step to get v. Alright, so we could actually break this up into a v0 over the v0 minus vi minus a v over v0 on vi. And then I could put that one over this side, so now it's positive. And then it would be v0, we've still got the v0 on v0 vi. And then we're minusing the e to the minus kt. Alright, just rearranging it, so splitting up that fraction and rearranging it. Alright, but we only want v, so let's multiply everything by v0 minus vi. So you can see this is just going to be a v0. If I multiply this one by v0 minus vi, it's a bit more exciting. Alright, and I can also see from what I'm trying to get that they factorize by a v0, so I'm going to factorize by a v0. So here you can see I'm going to get a minus v0 e to the minus kt, so that can be factorized. But I'm also going to get a plus vi e to the minus kt. And that e to the minus kt. That doesn't have a v0 in it, so I'll balance it by putting a v0 there. All right, so we're getting closer. So you can see there's a 1 minus. All right, if I factorize by e to the minus kt here, I'm getting a 1 plus, so it's going to be a minus minus to make a plus. And this will be a vi on v0, e to the minus kt. All right, so just playing around with the algebra of it. And then if you have a look at it as t goes to infinity, you see really we've got this v0, 1 minus, let's put like e to the kt here, that bracket. And as t gets really, really large, this fraction here is going to go to 0. So as t goes to infinity, v is going to go to v0. That doesn't look very good, but yes. So the limit of v as t goes to infinity is the v0. So then if we look at the two different cases where vi is bigger than v0 and then where vi is smaller than v0, knowing that as t goes to infinity, the velocity goes to v0. Now let's make some stuff up. So let's go for the first one. Well, let's make them both have both cases have v0 equal 2, but in the first case we'll make vi equal 4 to be bigger. In the second case we'll have vi equal 1 to be smaller. All right, so what do we have? We're looking at this v and this t. This was very badly drawn. But you're used to my terrible drawings. There's t. All right, so we know that it's going to go towards v0, which I made. Actually, I might make it here, which I made 2 in both cases. And then we know it starts at vi because that's the initial one. So if I look at, this is 1, if it starts here, you can see even if I sub it in that equation, I'm looking at the bottom one first. 2, 1 minus 1 minus 1 on 2, e to the minus kt. So that's going to be 2 lots of 1 minus a half, e to the minus kt, which is the same as 2 minus e to the minus kt. So you can see when it's at 0, we've got 2 minus 1, which is 1. And we knew that already because vi is 1. So we know it's going towards 2, but it never reaches 2. And then if I look at the first one, going backwards here, 2, I get 1 minus 2 on 1, 4 on 2, e to the minus kt. And that will give me 2, 1 plus e to the minus kt. So we know, anyway, we don't even need that because we know it starts at 4. Let's say 4 is up here, and it goes towards 2 as t approaches infinity. So you can kind of see the pictures of them. All right, so then the last thing we had to do, let's just go back to what we did have to do. I have to go up to remember. Oh, there we go. So we need to find the time taken for the box to accelerate from 1/3 v0 to 2/3 v0. All right, so let's use this then. So we've got negative, when we integrated we had negative k log of p minus. So I'm going to use that. But this time we've got a definite integral. So let's make it a definite integral instead. All right, so let's make it negative 1 on k, oops. Let's say v0 on 3 and 2v0 on 3. And let's change it as well so we don't have any p's in there. So let's change that like we did before. So it's log of all of that, but this time we've got the limits. All right, so we've got negative 1 on k. So let's put them in. So I've got log k of, so when I put v0 minus 2/3 v0, that's going to be a third V0 minus log k. And this time V0 minus a third V0, so it's going to be 2/3 V0. So negative 1 on k log k V0 on 3 over k 2/3 V0. And you can see there, even though my working is too bad to see, the k's cancel, the V0's cancel, the divided by 3's cancel. So all you're left with is log a half there. So you've got 1 on k log of a half. We could put that negative in also, so a half to the power of negative 1 would be 2. So we can make it 1 on k log 2, and that looks even better.